Before 1893, the world of solving crimes was often the flip of a coin, or better yet, pinning the tail on the donkey, blindfolded and facing the opposite way. Murders were solved by eyewitnesses, basic inference, and rudimentary evidence, such as the presence of a murder weapon or a broken window. Though if any of these were lacking, the murder may go unsolved, or worse, someone is wrongfully convicted. Thankfully, in 1893, Hans Gross, a reputable scientist of his time, introduced the idea of merging science and criminal justice with the birth of forensic science. For many of you, the closest you get to crime right now is on TV, though unfortunately 80% of you will be the victim of a violent crime such as robbery, rape, or assault at some point in your lifetime. As a victim, you would want your case to be solved accurately and swiftly, and the evolution of forensic science over the past century has made this possible. There are three main fields of forensic science that have made leaps and bounds of progress, which include blood spatter, DNA, and fingerprinting. Let's start by examining how blood spatter analysis went from a simple evaluation to a very complex and precise science. According to the respected and experienced professor, Dr. Chris McNair from Hardin-Simmons, the beginning of blood spatter analysis was actually not too long ago. In 1939, Dr. Balthazar first looked at the interpretation of bloodstains at a crime scene. He examined the ratio of width to length of a stain to determine the angle of impact and the velocity of which it occurred. He also discovered the stringing technique, which determines the point of origin of all the bloodstains within a scene. It wasn't until 1950, during the infamous Sam Shepard trial, where key witness Dr. Paul Kirk was called to the stand. Kirk recognized and testified to the value of bloodstains in crime scene reconstruction. Through bloodstain analysis, Dr. Kirk was able to establish that the murderer was left-handed, the murder weapon was cylindrical in shape, and that the large bloodstain found by the door was the perpetrator's bloody handprint. Finally, in 1983, the International Association of Bloodstain Pattern Analysts was formed. All over the world, IABPA promotes education and establishes both training and practical standards, and also supports and encourages scientific research of blood pattern analysis. Through IABPA, blood pattern analysis is a respected and trusted tool in crime scene investigation due to its ability to order the events of a crime, place the victim and the perpetrator within the scene, determine the number of blows, where the victim was hit, as well as what type of weapon was used. Another key discipline of forensic science that has seen amazing technological as well as scientific advances is DNA analysis. DNA analysis didn't always have such an intense role to play as it does in forensic today. On the word of renowned as well as trusted forensic magazine, DNA analysis was first developed as a method to determine paternity where samples were taken in a clean, controlled, and clinical environment, though it finally made its big breakthrough in the courts in 1986. Police in England asked molecular biologist Alec Jeffreys, who had begun investigating the use of DNA in forensics, to use DNA to verify the confession of a 17-year-old boy in 2 rape murders. From the DNA test, Jeffreys was able to prove that the teenager was in fact not the perpetrator, and that the actual attacker was eventually caught using DNA analysis as well. The first U.S. conviction from DNA happened in 1987. The Circuit Court in Orange County, Florida, convicted Tommy Lee Andrews of rape after DNA tests matched his DNA from a blood sample with that of the semen traces found in the rape victim. DNA testing went from gathering samples in an office to gathering samples in contaminated, muddied, and decaying crime scenes, and is still able to convict and exonerate suspects. Lastly, the forensic discipline of fingerprinting has made drastic improvements in identification and application. Fingerprinting actually has a very ancient beginning before its premiere in forensic science. Knowledge of fingerprints dates back thousands of years and were used in contracts in China and Japan dating around 1000 BC. Fast forward to 1892, Sir Francis Galton published his book, Fingerprints. As stated by the U.S. Marshal Service, in his book, Galton concluded that fingerprints do not change over the course of an individual's lifetime, and that no 2 fingerprints are exactly the same. In fact, according to his calculations, the odds that 2 people have the same fingerprints are 1 in 64 billion. Galton also identified the characteristics by which fingerprints can be identified, and these same characteristics, called minutiae, are still used today. Just a couple of decades later, in 1901, was the introduction of fingerprints for criminal identification in England and Wales. Galton's observations were used and revised by Sir Edward Richard Henry. This was the beginning of the Henry classification system for fingerprint identification. This is still used today in all English-speaking countries. In 1903, we saw the first real use and implementation of fingerprinting in the New York State prison system. They began the first systematic use of fingerprints in the U.S. for criminals. By 1946, the FBI had processed 100 million fingerprint cards in manually maintained files, and by 1971, 200 million cards. With the introduction of AFIS technology, which is Automated Fingerprint Identification System, the files are split into computerized criminal files and manually maintained civil files. Today, fingerprint cards are still in use and are being processed for all different kinds of identification purposes. These cards allow us to identify fingerprints left at a crime scene and determine who was there and who was actually the perpetrator. Now that we have covered these three main fields of forensics, let's recap. Forensic science has come from non-existent to one of the essential foundations of criminal justice and crime scene investigations. Crime scenes are no longer just glanced over. There is valuable evidence that can now be processed and used in the court of law. Although vast in its disciplines, forensic science has seen the most development in three categories. In blood pattern analysis, we have come from blood merely being at a scene to it telling a story. DNA has advanced from a clinical setting to that of the real world and real crime. And fingerprinting went from one state to an entire nation. These developments have changed the way we look and solve at crime for a drastic improvement.